Okay, so in the interest of everybody's time, I think we can probably get started. Um, well, as other people come on, I'm sure they'll join in progress, but don't want to waste anybody's time for today. So, hi everyone, thank you for attending. Welcome to what we're calling information session hosted by All Control and SICK. My name is Jim Staniszewski. I'm the Director of Sales and Engineering at All Control. Today, we're talking with SICK application and product specialist, Jim Anderson. He's going to be discussing SICK's new vision inspection product known as the label checker. The label checker is a vision sensor that has barcode reading and OCR, which is optical character recognition capabilities. Gives you the ability to perform some standard vision inspections, but also allows you to be able to read printed date codes, 1D or 2D barcodes on products at some pretty high speeds. It can go over even 4 megapixels of resolution, so you can see some pretty small details and codes as well. For those of you who are unfamiliar with SICK, or if you didn't join our first group of information sessions, SICK is a manufacturer specializing in sensor intelligence. That includes vision inspection, safety controls, presence detection, and automatic identification technologies, and pretty much used in any manufacturing industry throughout the world. All Control, which is the company I work for, we're the local technical resource and distributor for SICK. We've represented SICK for 30 plus years. We have a group of sales and application engineers locally in Illinois, Wisconsin, and Indiana, and we can hopefully assist you with all your automation applications. Restrictions now, especially in Illinois, have started to loosen up a little bit. I know most places in-person meetings are still a little bit limited, so we're still thinking that these information sessions would be a good way to kind of communicate new products and applications to our customers. Keep in mind that these are definitely informal sessions. We're not pro webcammers, so feel free to chat in questions or even interrupt if you have questions as they come up. Right now in the third quarter of 2020, we're focusing on vision inspection and automatic identification. So if you have any applications for that or any other type of applications we could help you out with, please reach out and let us know. And we can tailor some presentations to your specific needs. So right now I'm going to introduce Jim Anderson. He's going to explain how the label checker and SICK's vision solution portfolio can solve some tough applications and optimize your machines.
Well, thanks a lot, Jim. Again, Jim Anderson here from SICK. I've been with SICK for quite a long time, and I have a lot of experience in different industries. So like Mr. Staniszewski said, if there's any questions, please throw them out there. We'll try to answer them the best we can right now, but we know the label checker is why you're here, and we want to give you a chance to see that. So I'm going to go through a couple of slides, go through some applications, and then show you a demonstration of the software and the camera working on some samples. I do see that there's a couple people also from SICK. Lucas Dendura was our regional sales specialist based out of Wisconsin, but covers with All Control, another resource that's available to you. And I also see Fred Hassmeyer, who is the Division 8 or our vision and code reading specialist in the Chicagoland area. So a couple of those people are also online. So lots of support for you guys in the Midwest region here. So feel free to reach out if you do have any questions. So the label checker, what is it? The label checker is for us is a way for us to really increase the competitiveness in a growing 2D marketplace. We see a lot of different camera solutions out there, obviously from some of the big players, Cognex, Keyence, Omron, other cameras, and we wanted to come up with a solution that would be obviously competitive, but also unique in some ways, and that's where we think that the label checker really steps forward. It has a lot of high-end tools, but also a very simple user interface, no software to install, basically all done through a web system. Very powerful optical character recognition with the optional deep learning technology built in for improving reads, and also 2D inspections for uh, pattern matching, blob counting, measurement of position of a label or the size of a label. So lots of different things that the label checker can do. And then it's all in a predefined small package, uh, uh, and easy to operate user interface. So only the tools that you would kind of use for these applications, but also part of a larger system that if you wanted to expand into our rest of our portfolio, where you would have access to a greater imaging library if needed. And this is just another way of saying that, but one of the key points on this page is that this is based on our SICK app space architecture. So we have a set of hardware and a programming language that we can install very specific application solutions onto that hardware for a customer. And we have partnered with a global software company, MV Tech, who makes the Halcon imaging library, and we have that also built into the SICK devices. So you have the SICK library and the Halcon library available for really pushing those vision needs if needed. The portfolio, like I said, we have a base set of hardware that is used across these different products, and the label checker and the lector are all based on the same platform, but a matter of what functions you can do and what software basically is loaded onto those devices. So the lector is a barcode reading with some OCR capability, or the label checker is a full vision system with true OCR code reading and 2D inspections. And then on the far right there, you have the Inspector P, which is a fully programmable device, so you can write any code that you wanted to basically and put that onto that type of camera. And we've basically taken that Inspector P, written a very specific application, and that's what we call a label checker. So what does a label checker do? It checks for the presence of labels, logos. So you can use something like the SICK logo on this in this picture to identify that it's the correct package or logo. Once you find that, then you can start to do some measurements. Say I want to measure the width of that label, maybe the distance from the edge of that label to the edge of the package to make sure that it's positioned correctly. You can read characters and verify that they're the correct characters. Read multiple barcodes, 1D and 2D simultaneously. And then if you did need to add something in there, you could check for printed patterns, measure different pieces, but you could also add some of your own custom software if really necessary. A number of different versions of the label checker exist, ranging from our label checker 631, which is a 1.3 megapixel device with options for a S and C mount lenses, going up to the label checker 654, which is a over 1-inch optics 4.2 megapixel camera with options for both manual C lenses and a autofocus lens that we have in that platform. So quite a range of products depending on what your needs are for your application. This is a platform based on the Inspector P. So we have a number of pieces that you can buy the individual camera, lens, light, and hood, or you can buy the label checker kit, which has all these things already pre-assembled. Then you would need to buy a gigabit Ethernet cable and a power I/O cable, depending, and all these are available in multiple different lengths and options, depending if you're connecting it directly to power, if you're connecting it to one of our connection boxes. We have double-ended cables that make it even easier to mount the camera. The label checker for us really opens the door to a number of different industries. SICK plays in all these different industries already: packaging, pharmaceutical, electronics, logistics, food and beverage. We really see the label checker having a strong play in the packaging, food and beverage, and some in the machine building, as the ability to do batch codes and read .peen codes and laser etched codes is something that the label checker does really well. That also gives way to some automotive applications. Logistics is something that we can do because we can verify print quality and label position and read the barcodes, obviously, but we tend to have other products that are maybe a little bit more suited for the logistics market. But packaging, food and beverage, automotive, and machine building are the main places that I would see the label checker being used. We have a number of different applications and success stories that we've worked on already. In this case, this is a automotive application where we're looking at the skid number on the base of a carrier for a car body. So the application here was to verify that the tag on the car matched the carrier information before proceeding with any paint and welding. So there's next to this system is a RFID reader that's reading the RFID tag that's connected to the body of the vehicle. And then there's underneath the car, there's a carrier number with a etched out number. And we are using the OCR functions to verify that carrier number matches the RFID, the information in the RFID tag to say that they match before proceeding with any of the additional functions in that robotic cell. Because they are both based on the SICK, what we call the ID4 platform, they have the same communication protocols. Our RFID channel and our label checker can communicate seamlessly, and one can pass that information to the other saying yes or no, that is a match. Another application is, obviously checking food labels. In this case, we're looking to control, just read barcode and make sure that the object locator, using the object locator to find the barcode. So in this case, there's a pre-printed label. We find the position of the logo, and from that logo, search for the position of the barcode. It's a really simple setup: photo eye, trigger, tell the camera when to take an image. We have a strong OCR functions built into this, or we have the ability to use several native fonts that are built into the camera, which is a difference from a number of our competitors. A lot of our competitors have the ability to do OCR, but all the text and fonts must be taught. Whereas with the label checker, we have several fonts built in, including OCR, A and B, a universal font that checks basically all the fonts that are possible. And then you can, if you can further identify which font it is exactly, you can get slightly higher performance in speeds, because it doesn't need to search and test all the different character possibilities. But using OCR, you're able to do more than you can with just barcode. Barcode will tell you that it's the correct package. OCR can tell you if that use by date or the information on there is printed legibly or completely, so that the customer can read it. Also gives you another way of tracking to make sure that you have didn't have like a human error in entering that information into your printer, so you can check and verify that the code actually matches with what it is supposed to be on the box. Now, using the application functionality that built into the device through Halcon, we're able to do some more functions, especially on these etched codes. This is a very good and high quality etched code, but this is one of those functions where we have multiple algorithms, one from SICK, one from Halcon, in which we can offer different functions in reading these types of codes. The SICK algorithm is a little bit faster in reading the barcode, whereas the Halcon algorithm does allow for a little bit more, say, damage or say non-conformity to the standard, so we can read those when they are etched, maybe with a little bit of not to the correct depth or the uneven depth in their etching, but still doing OCR, barcode, all simultaneously, giving you as a user a lot of flexibility to have one device that can really help you in your control system. So here's maybe let's say the most standard type of label that we've seen so far, but basically reading a 1D, 2D code, also reading some OCR. You can see that the camera doesn't care if the text is upside down or right side up. We can invert that image, or we can search and tell the camera that text is going to be one way or the other. It could be vertical. It could be even diagonal. As long as we know where that text is supposed to be, we can do the correct type of segmenting and then pull that into the OCR algorithm and tell you what characters they are. So this is a really strong kind of view of what we can do for the OCR and multiple codes at the same time. In this case, we are using the logo to identify if that part, which direction that part is, and then once we find that logo, we then know where to search for each of those individual inspections. One of the features that is not typical in a simple to use say a sensor like the label checker is some of the functions like the rectification feature here. So what we have is the ability to calibrate and say unwrap a label to make it easier to read and make it and also to compensate for any distortions that might be in the lens or just in the printing process. So we can take this label is going to be rounded around the circumference and this arch. If you're just reading the barcode, yeah, that's not so hard. But if you're trying to read the text, this text is not in the same line. It's not necessarily even looking like it's the same size because it's going to be a little bit further away on some sections than the center at the tangent point. So when we use the rectification feature, we basically unwrap that, get that a flat image, and now all the characters are say scaled appropriately. We can read the barcode, read that human readable text, and also check those logos without having to do any fancy issues with scaling and things that could slow down the camera. So not only does it do the barcode, OCR, and those types of applications, it is capable of doing simple inspections as well. Is the label in the correct position? Is it in the right location relative to the shoulder? Is the cap on? Is the cap seated completely? Using tools like the pattern match measurement, blob tools. So there's a number of different things that can be done also on board the label checker. So, excuse me, if you wanted to count the number of bottles, and then there was a code printed, say on the top of each of these lids, you could read all those codes and count them based on the presence of the code, presence of the of just the cap. So you could say there were 12 bottles, 11 of them also had codes that were red, and that could give you a pass fail criteria if there's a certain percentage of those products that needed to have printing or other types of inspections before they were allowed to pass. One of the first major customers or users of this was a company that makes chocolates, and they were reading what is actually a pretty long OCR string, two lines, barcode, and in this case we were doing this in about 15 items per second. At the end, the original function of this product was that it needed to be able to do 4 labels per second. After doing testing, we were able to achieve 15. They were able to increase their speeds slightly, as there are other aspects of their machinery that couldn't keep up beyond the 4 labels that they already have in their process. But this gave us a lot of encouragement that the system has a lot of room overhead, so we can get in there and give a strong solution without really slowing down any production, giving both strong code reading and OCR functions. One of the features that one of our competitors talks about a lot lately has been the addition of AI or deep learning into the code reading or OCR functions, and that is something that the SICK also has in our OCR. We have the ability to continually add additional features and text to our library, increasing the reliability of the reads. So if you have very difficult characters that are often missed based on their print location or their the text or font that is required to be used either by manufacturing, what's available on your printer, or what's being dictated by marketing. Sometimes those things are not always done exclusively. I mean, so the marketing might have some control as to what that text needs to look like, where that might not generate the best, say, machine readable code. So having the ability to add in additional functions and have that deep learning neural network functionality to add reliability to your read is something that SICK is very proud of, because it does really change the game a little bit when you're trying to read characters that are often misprinted, or if you start to have things that as the printer speeds up or slows down, or the packages are not maybe processed exactly at the same speed, you can start to get, say, slanting or some bunching of the characters. And using that deep learning, we have the ability to identify and still segment those features and give a good read. So one of the things that we know is a advantage in this product is the ability to identify and still segment touching characters, dot print characters. We have the ability to mask out and read a number of different types of barcodes, so we can look for just the presence of in that segment there, number 3, we could look for just the presence of that square, use that as a reference, and regardless of what is printed internally. We could use a barcode as a object locator. We can use the functionality to both read standard and inverted text and codes. So depending on how it's printed, if it's laser printed, etched, or dot peened, we have the ability to read those types of codes regardless of how they're printed. And then we have some additional inspections that we can do with measurements, it can be calibrated measurements, so we can calibrate the system to give you actual millimeter values as opposed to just pixel values. Multiple jobs, so you can have a system that would send a signal to the label checker, which would allow the information that we're looking for to be switched quickly, have those jobs up and running without having to teach them every time there's a changeover. Depending on which version of the label checker you're using, you would also potentially have different fields of view that you could use. The device that I have here for my demonstration has a dynamic focus function, so I can change directly from the software the focus position of the camera, where some devices would require a change in the position of the lens through a manual adjustment. Again, some additional features that we can do: label positioning, image rectification, and then one of the reasons that this is becoming more and more of a need is that the label contents detection, looking at if there's potentially allergens or additional symbols on a label, to make sure that those are actually there. If you're working with, say, I guess gluten's becoming more and more that way, but definitely peanut and peanut butter have different functions that are requirements for labels to make sure that those are detected before going further. We have the ability to add a micro SD card for cloning. So if you had multiple devices or something happened, you could take the settings out from the SD card, plug it into the next camera. It would be up and running basically immediately, other than the focus of the camera. We have both a dual core processor and an FPGA. So we offload certain functions of the camera to the FPGA to speed them up. And all sorts of other features, including an aiming laser, so you can see easily if you're at a distance where the camera is looking. Here's a quick grasp of the user interface. It's a web page. So on the left-hand side, you have your different tools and functions. A center panel with could be a live image or the last captured image, and then the results are shown on the right side. So you can tell the camera to take one snapshot or take continuous inspections, and you can save the images. The images can be saved to an FTP or directly to that micro SD card. So again, flexibility and functionality built into the label checker at a lot of different levels. It's a compact, all-in-one system with multifunction and combining multiple label inspections, making it truly a true label checker, not just barcode or OCR. It has those additional inspections as well. High reliability and say robust options for deep learning based on the SICK and Halcon algorithms. It's a flexible design, so you can adjust the lighting and or lensing to fit just about any application. And then there are multiple programs that are available through job switchings to make it even more flexible in your production line. So with that, I would like to go ahead and actually show you a live setup that I have here. I'm going to start my camera and show you the setup that I have. I have a camera mounted about 1 meter above a printed target, giving me a real strong focus for this lens that I have available. And then I will go ahead and show you here in the software. So I type in the IP address of the camera. And you should type it in correctly.
While Jim is doing this, I think it's good to point out that that camera that you have, that has the ability to, you can change in or out the lenses, you can change in or out different kind of lights depending on the labels you have. Um, so even
Right.
though we like to call it a vision sensor because it's kind of an all-in-one unit, um, it still has that ability. So you can cater your application, your label size, your resolution to what you need uh, in the same kind of hardware. You're not limited.
Uh, Right. And so just to kind of give you an idea here, so the camera has multiple user level access. So as an operator, I would be able to come in here and see what's happening. And if I had multiple jobs, I would be able to switch from one job to another, but I don't have a lot of ability to adjust the settings of the camera. So you have a service level. And when I log in this way, I now have access to all the programming. I can see all the items that the person could see as a uh, operator, but also I have a lot more information. So you'd start out by gathering and setting up your camera to get um, a good image. So like I had mentioned, the device that I have has a dynamic lens. So built into the camera, I can adjust the focus. So if I change the focus to 1200, you can see that it starts to get a little bit fuzzy. Or if I go to 600, that's too close. So but if I had it at, now I get a strong image. I can go now back and I can add in, I can save that image, and I can go to the next tool there and I can add in the object locator, or I can add in an OCR tool. So when I have a image, I can go in here and I would say add an OCR region and simply drag that to the area that I'm interested in reading text. Highlight that with the tool, and then apply that tool. And automatically, without any adjustments yet, you can see that I'm picking up all the main characters. It is currently, say, skipping over the colon. So if we wanted to read that colon, I would have to add in some adjust the size and shape of the characters that I'm trying to read, or maybe adjust the font that I would want. So you can see here on this preset one, what I've already done is I've put in a small dilation filter to make the dots show up, because right now those dots are not showing up as a large enough to be considered a character. Then I can go into the barcode section and I can add in a 1D code or a 2D code. So in this case, I'll add in another 2D code. Same as before, just drag it to where the code is and apply, and then you get the readout of that text. Now there's a lot of other information that is available. So if I go into the run mode here, and I can kind of turn this on in a continuous manner, you can see that these are reading these, and I can get the detailed result on each. So I can look at each of the individual characters, how well it's reading. I can get information about where that text is being read from on the box, and I can also then get that same type of information on the barcodes. So I have the 1D and the 2D code here, where it's giving me what it's reading out and the position, and it keeps updating. So if I go here just to the last read, it shows me the row, position, the print quality, and the overall time it took to read that barcode. So it gives me all that information in a relatively simple setup. I have the ability to FTP. So if I have a location that I want to send these images to, a lot of times people want to save the failed images. This is also a very good idea for if you're trying to improve the readability using the deep learning functions for the OCR. You save the failed characters, and then you can go back in and add those into your library, and that will increase the readability in the future. You can set your IO as to what a lot of functionality as to what you can and can't. Do I want a digital IO for just the barcode reading? Do I want an all pass? I have a lot of flexibility there. Also a lot of flexibility in what the output string would look like and what types of communication protocols that would go out as. So it could be Profinet or Ethernet IP, standard TCP IP. So a lot of robots have options for either of these two communications, but almost all of them have options for TCP IP if you're trying to use the location information to guide a robot or to, based on the position of a barcode, reject or pick something up. And all that same information can be sent out not just over Ethernet, but also serially. And if you're familiar with any of our other products, you have the ability to build up your output string. You can, it's not predefined. You can choose which order, what separating characters, and what parts of that tool are sent out. So on a like the object locator, I have the opportunity to send out the XY position, the rotation angle, and also information about how well it matched. So there's a number of different things that I can send out without having to do any, say, programming at all. Some general statistics, how well has that been working? And if any of the fonts that are built into the system didn't work, we do have the ability to kind of go in and program those like you would with any of our competitive systems. So lots of flexibility in the back end of the label checker to kind of say tune it in specifically for your application, but also just the simple user interface on the front end to be able to drag and drop some tools and then identify if you want those tools to be in a specific area, like I did here. It has to be in this search region, or I can have it be anywhere within the image. So identifying how flexible and or how restricted you want that system to be, the label checker can really help you identify some of those problems that come up in the food processing, packaging industries. Is there any questions that anybody has at this time? Any applications they would like to discuss?
Yeah, I think the good thing, the product is called the label checker, but it can be used for a variety of different applications. I mean, we're looking at labels with barcodes and OCR or characters on them. But like Jim showed earlier in the presentation, I mean, he was looking at literally a car on a rail. We've seen a lot of different applications where barcodes have been printed on products, whether they're metal, plastic, or laser etched or dot peened into a surface. So yeah, I mean, by no means is it limited to specifically only quote unquote labels. There's a lot of different applications that wouldn't be a label that you could use this guy for. And it does have some standard type of vision inspection tools as well. So if you're looking to inspect something on a part and also read code or characters, that's something that this has the capability of doing as well.
So one of the things like I would point out, like if we tried to use a traditional OCR on the SICK name, it would find the I, the C, and the K. The S is not a defined font, defined in any font. It's a drawn character. So that would be something that we could then teach in using our font teaching function. But it would not work with a standard because it is not a it's a drawn character. So a lot of times in labels, if you're trying to read that kind of stuff, companies have unique characters built into their name to have their brand stand out a little bit more, and that's one of those areas where that font teaching can come in, or you can go to another way and just teach that entire shape, including all the characters, as a pattern, or use that as an object locator. So a lot of different ways to work with the different tools in the label checker.
Yeah, that's kind of a good point to bring up too, because I mean, obviously there's an unlimited amount of fonts out there and different kind of label types. So one of the good things about this product is that there's a lot of them already kind of taught in there and saved for it from SICK, but you know, extra things on your products or on your customers' products that are different kind of text or fonts that can be taught as well, and that gives it the ability to kind of read any kind of printing.
Correct. So that's what I have for today. If there's questions, I'd be more than happy to take them, or if you wanted to follow up offline directly, feel free to contact the people at All Control or myself, and we can work through one of these applications with you. Oh, here's a question that came up. How about just to verify there is a white alphanumeric type on the package with various color boxes with no change to settings? So if you're just looking to verify that there is, do we need to know if it is an actual character, or just that there is something white printed on there regardless of the background? There's a couple different ways to do that. If it is a known character, I mean, let's say it's the letter X. If we're trying to find that letter X, and we know it's always going to be a darker color background, we can set that those settings and search for that character. Or we could use something like a blob tool, which would search for changes in contrast and highlight that, and then we could verify that that is there in certain areas of the label. So there's a couple different ways to do that.
Yeah, I know the application that he's referring to. It's basically boxes of all different kind of colors. The issue there is to filter out the different colors. So if you go from like a darker color to a lighter color, like dark red to yellow, it's kind of difficult to filter out those colors on a standard vision sensor without changing the application.
Some of the settings, yeah.
Yeah. So
now that'd be one of the questions that looking at that type of application would be: is it clear as to whether or not we know what the next package is? Is it done? Are they done in blocks, or are they randomly coming through the line? If we know that they're running this color or that color, I mean, it could be easily changed over by the job, or just having that changing the contrast values based on the job setting.
Yeah, I think
Jim, we can also consider IR lighting as well, because IR lighting tends to mute all the colors too.
Yeah, I think that's the next kind of way we're going on that one, because they don't want to switch between colors. So when they are running batches, so they're running one color at a time, but they don't want to have to switch between reference objects or products in the sensor.
Okay.
So yeah, I mean, that's one of the benefits on this particular sensor, is that we can change the lighting in there, and it might just take a different ring light in there, if that works, then we can just pop that right into the face of the sensor. Everything else looks the same. So
Yeah. So on the, if I go back to the presentation here, I guess that's way at the beginning. And the fact that this lens and lighting here is replaceable or selectable based on your application, and we do have a version of this that is an IR light, so that they could all still be built into that self-contained housing. And that could help in those types of applications. But there's also blue and red and white. So depending on what the application is, you can help create the highest level of contrast with lighting. And then we can also add filters directly over the lens to maybe have a white light and then filter out other colors based on the lens, or vice versa. So you can increase contrast by the color of the light, and then you can filter those things out on the lens using different colored lens filters. So there's a lot of flexibility that's available because of this, say, built up solution.
yeah, I think that's a good point to bring up, just because now we don't have to focus on, the software or or bringing in external lights. We could potentially have that just replace that illumination in there, the standard one, with an IR, and we might be able to solve the solution. So
Right.
that
Yep.
gives us kind of flexibility in a lot of different applications to choose the lens, the light, everything based on that, and everything in the end still looks the same.
Yeah, so I think the device that you have, that you're borrowing of mine at All Control, I think it has like a whitish blue light in it. But I think in my hand here, I have the IR option that would go into that same camera. So we have those readily available for testing and on the shelf. So depending on what you need for an application. So be sure to reach out to the folks at All Control, and they can bring in the correct people at SICK with the correct hardware to, maybe, or a bundle of hardware to do some quick testing, or we can send in some samples to our Vision Lab in Minneapolis, and we can do some testing there where we have access to, all the different varieties and give you the best option for that application.
Right. Yeah, that's the kind of last point I wanted to bring up, is that especially in this Illinois, Indiana, Wisconsin area, All Control, we have multiple application engineers, we have demo product. If we don't have what we think we need, we can get it from SICK, which SICK's US headquarters is in Minnesota, and we have technical capabilities with Fred and Jim. Fred's local to Illinois, Jim's out of Minnesota. So we have a lot of support capabilities and demo products that we can use to solve all the applications. So if you have anything, please feel free to reach out to us directly. And if you want us to take a look at something, we can definitely do that. So if anybody wants to unmute themselves and ask a question, please feel free, or type it in the comments. Otherwise, we're running up on about 50 minutes here. I think everything was useful today. Hopefully you guys got something out of it. And like I said, please reach out and let us know if you have anything you want us to take a look at.
Thanks a lot, Jim, for having us. The people at SICK really appreciate the opportunity to talk to you and some of your customers. So hopefully we can turn these into live applications, or if there's something else that we can help with, please don't be hesitant to reach out.
All right. Sounds good, everybody. Thank you again, and have a great week.